Okay then, here's the question, parts A and B. It's good to have a go at the question first. Scroll down and get part C and the rest of B now. There's the rest of B there. Okay, so I've got the question summarized all here. So the first thing, let's show x plus 3 is a factor of this. Part A, x cubed minus 4x plus 15. So f of x is equal to x cubed minus 4x plus 15. We have to show that x plus 3 is a factor using the factor formula, factor theorem. So put in minus 3 here. We get minus 3 cubed. Minus 4 times the minus 3 then, plus the 15. Minus 27 plus 12 plus 15. And that equals 0. So x plus 3 is a factor. Okay, that's part A, part 1. Express f of x as this. X squared plus px plus q. So this is part 1. Part 2. So x plus 3. X squared plus px plus q is equal to x cubed then, minus 4x plus 15, and we need to find out p and q. So we'll equate the constant terms first. On the left we'll have 3q is equal to, and on the right we've got 15. So move the 3 from times to divide, and q is 15 over 3, which is 5. So that's the first one. Now we can equate x's then, or we can equate x squareds. Let's equate x squared, shall we? So on this side there aren't any, so equals 0, and on this side we've got px squareds there, and then we've got plus 3, haven't we, 3x squareds there, and that's it, that's the only two. Px squareds plus 3x squareds is that, there's no x squareds on the other side, so p equals minus 3. Okay, so there's the p and the q then from part 2. Part B, we've got this, find dy dx. So we got that, minus x to the 4 minus 8x squared. So I'll write it down now. Y equals x to the 4 minus 8x squared plus 60x plus 7. So that's the question, and let's look back at the question now. Sorry about this, it's a long question. Find dy dx and show the stationary points satisfy this. That's parts 1 and 2. So dy dx is equal to 4x cubed then, 2 minus 16x plus 60. That's part 1. Part 2. 4x cubed then, minus 16x plus 60 equals 0. Take a 4 out as common. X cubed minus 4x plus 15 equals 0. Divide by 4 both sides. X cubed minus 4x plus 15 equals 0. So that's B part 2. Okay, so we got the stationary points then. Show that stationary point, only stationary point is when x equals minus 3. So, we've got x plus 3 then. We've got x squared plus px plus q. From up here, p is minus 3 and q, and that was what we had from before. So we can see that that implies x equals minus 3. Now this has no roots, if b squared, which is minus 3 squared, is less than 4 times a times c. 4 times 1 times 5. So is 9 less than 20? Yeah, okay. No other roots. So basically that's what we're saying there, no other roots. And that should go in there, shouldn't it? No other roots, whoops. Since this is less than 20. So that's the only root then. So we've done that part. That was part 2. Part 3. Part 4, find d2y by dx squared when x equals minus 3. So that was part 3. Find d2y by dx squared when x equals minus 3. Differentiate again then, 12x squared minus 16, which equals 12 times minus 3 squared minus 16. 12 nines are 108, 102, 92, which is greater than 0, so a minimum. At x equals minus 3. So let's have a go back at the question. This is a max or min when x equals minus 3, which we've done. So that completes the question, I think.